Reducing atmospheric pollution is a global challenge to be taken up to protect human health and preserve natural ecosystems. The French National Institute for Industrial Environment and Risks, INERIS, is dedicating its scientific and technical expertise to serve this challenge. Road transport, industry, residential heating and agriculture are the main sources of pollutants of human origin. Atmospheric pollution is also fueled by natural phenomena, such as ground erosion and volcanoes. In the lower layers of the atmosphere, ozone is a secondary gaseous pollutant coming from chemical reactions in the air between diverse precursor pollutants. Ozone is formed in stable climatic conditions when there are high temperatures and abundant sunshine, hence the appearance of pollution peaks during the summer. The reduction of ozone pollution is an issue for the entire world, including, for example, for Mediterranean Europe or Asia. Ozone has a lifespan of a few days. Pollution plumes thus evolve far from their emission zones by a long-distance transport phenomenon. It is therefore required that environmental policies are coordinated at an international level. Suspended particulate matter have variable chemical compositions and dimensions. Plumes are formed of primary and secondary particles. Primary particles are directly emitted by pollution sources. Secondary particles come from chemical reactions in the air between diverse precursor pollutants. Particulate pollution is also exposed to the phenomenon of long-distance transport. Pollution peaks present different profiles from one region of the world to another, from one season to another. Particle pollution occurs during stable meteorological conditions. In Europe, peaks are often fueled in the winter by the contribution of residential heating and road traffic. In the spring, ammonia resulting from fertilizer spreading can combine with emissions from road traffic and industrial activities. Nitrogen oxides are precursors of ozone and secondary particulate matter. Such pollution is rather localized. It forms around emission zones where human activity is the most intense. Ground erosion generates massive plumes of desert dust. Saharan plumes are transported across the Atlantic as far as northern Europe and also affect regularly southern Europe through the Mediterranean Sea. Under the influence of transatlantic flows, Saharan plumes make up a significant source of atmospheric pollution in the West Indies. Volcanoes can emit very significant amounts of ash or sulfur dioxide, as we see here for an Icelandic volcano. INERIS mobilizes the achievements of scientific research for the evaluation and control of industrial and environmental risks. Air quality maps are produced with the Chemistry Transport Numerical Model, CHIMER, co-developed by the Institute and CNRS. The unprecedented precision of these simulations was obtained with the CCRT supercomputer Cobalt. They are used to guide the improvement of air quality and forecast pollution peaks. We thus find them on prever.org, the national platform for forecasting air quality, developed and managed by Ineris.